Good afternoon, everyone. Yeah, so as Julie kindly introduced, Jonathan Reynolds, I'm the Vice Chair for the East Anglia branch for IIRSM. Happy to be sharing our third webinar since the launch of the branch. We're greatly appreciative to Les Young, who's come along to talk to us today around machinery safety. Machinery safety is always an issue across industry, and PUWER in particular within the UK, because it does have a wide range of absolute duties within it. So we're lucky to have Les volunteer to offer up his insights into PUWER, which is fantastic. Previous webinars that we've held are available on the YouTube channel. So we've had a previous webinar from John Nelson on organisational change, and our previous one from Glenn Ridsdale on the infinite game. Again, they're available on the YouTube channel. Brief update on the Risk Excellence Awards. They've now closed with in excess of 120 entrants, which the judges have got to rigorously go through and select just the awards available. But thank you to everyone who did offer up an entry into those awards. Without further ado, though, I will pass over to Les, who will take you through this afternoon's webinar. Over to you, Les.
Good afternoon, everyone. Welcome to the webinar. What we plan to do today is try and take you through the fundamentals of PUWER with regards to application of machinery. The presentation I'm going to give you is a heavily abbreviated version of the one-day training course we do on PUWER, but the idea is to give you the key principles and the key ideas of what PUWER and machinery, how they go hand in hand with each other. That's myself, you can see on the screen there now. Without further ado, I'll start going through the presentation. My contact details will be on one of the slides near the end of the presentation, so feel free to grab a pen near the end if you want to grab my contact details. So fundamentally, there's some things to remember when it comes to PUWER. In our world, we quite often get asked, can you do me a PUWER risk assessment? There's no such thing as a PUWER risk assessment. There's a PUWER assessment, there's a machinery-based risk assessment, and a task-based risk assessment. They're both, the PUWER assessments and risk assessments are fundamentally different, although they do have some correlation, and they're both legal requirement in the UK. As you can see from the screen, a PUWER assessment simply checks the integrity of a machine against 15 basic regulations, which are regulations 11 to 24, or 24 regulations if you include site policies and procedures on regulations 1 to 9. So a machinery-based risk assessment has to be carried out under the scope of EN ISO 12100, and it has to identify every hazard on a machine, it has to quantify it, and it has to give risk reduction measures. A task-based risk assessment is something which a site health and safety manager could do in terms of lifting and carrying and things like that, and noise and that sort of thing. A PUWER assessment, as I said, there's set of regulations. You can't just say yes or no answers, but if you do that and you end up with a 1 or 2 page PUWER assessment of a machine, you're in the territory where the HSE would consider it to be unsuitable and insufficient. The last point on that, a PUWER assessment should never be used as the starting point for remediation of a dangerous or unsafe machine. That should always come from a risk assessment, because if you remediate from a PUWER assessment, you may find that you solve one problem, but you're going to introduce another one which you haven't previously identified might be the case by doing a risk assessment. So 3 fundamentally different things, all legally required in the UK. Okay, so Provisional Use of Work Equipment Regulations is from 1998. If you want a copy of the regulations, you can go to the HSE's website and download a copy PDF free of charge. They will try and sell you it at the top half of the page, but just scroll down to the bottom and you'll find that you can download a PDF copy. It's also available from the usual booksellers and online retailers and things like that if you want to grab a copy. So the scope, PUWER's law, you have to comply with it. And the objective is to make sure that the machines are made available for people to use at work. The employer shall take the necessary measures to make sure it's safe. That word shall is vitally important. In our world, there's a difference between shall, should, and must. They mean 3 different things. Shall means you're going to do this, you have to do it. It's a legal requirement. So PUWER regulations apply to all work equipment, regardless of age. It includes CE and UK CE marked equipment, brand new, leased, in some cases hired equipment, depending on how long you've had it hired. One example could be a compactor baler you may have in your site yard, where the owner of the compactor baler lends it to you or rents it to you or gives it to you to use on the basis that you give him all the waste that comes out of the baler. You are not the legal owner of that, but you are the operator of it. That is the grey area whether the owner, i.e. the waste company, or you have to do it. But if it's been on your site, I would suggest for anything more than 6 months, take it as read that you should be doing something about it. The regulations also apply everywhere where the Health and Safety Work Act applies. They go hand in hand. If you look at prosecutions from the HSE, you'll find in various prosecutions that they put on their website that people have been prosecuted under the Health and Safety Work Act and under the PUWER regulations at the same time. So they work with each other. And it also applies to certain areas offshore and within territorial waters. So compliance with PUWER doesn't require a UK or a CE mark. It doesn't require a technical file to be produced or a declaration of conformity. But the regulations ask if all those things are in place. So you can do a PUWER assessment, and your machine has the potential to fail the PUWER assessment if it doesn't have a CE mark or a UK CE mark. But it's not a requirement for PUWER, because PUWER applies to machines irrespective of age, and CE marking only came in 1995. We regularly see machines that are still in use from the 70s and 80s and early 90s. They have to be PUWER assessed, but it doesn't need a CE mark. Because of its age, it wouldn't fail the PUWER assessment. So when you do a PUWER assessment, when you first buy it, when you go to use it, which in terms of a factory machine would be after installation and commissioning. So you have to PUWER assess it before it's put into service commercially for the first time, or if you move it. In terms of moving it, that means even if you move a workshop lathe, for example, a couple of meters across your workshop floor, you should at the very least revisit your existing PUWER assessment and make sure you haven't compromised its safety. What you can do by that is an egress route from an operator. If he starts to get entangled in the chuck, for example, if you've turned it around 90 degrees and now it's facing away from a wall, so the operator's back to a wall, he may not have enough room to step back and step away from it if something starts to go wrong. You don't have to redo the PUWER assessment. You need to revisit it to see if your existing one is still valid. Sorry, got a twitchy mouse. So as I said, PUWER applies to all work equipment. You also have to re-inspect it if it's been subject to damage. Clearly in the case of the picture we got on the screen, the rollover protection structure would have been damaged, so that would need to be replaced on this one. Generally, whenever a situation is concerned where it could potentially compromise the safety of the machine, the PUWER assessment should be at the very least revisited. But in most cases, if it's reasonable level of damage, you will need to reassess it and create a new PUWER assessment once any repairs have been completed. PUWER spends a lot of time talking about maintenance. The key thing is it requires planned preventative maintenance on all work equipment. So if you're in the position when you're only carrying out reactive breakdown maintenance for whatever reason that may be, in case of finance folks within your company trying to save a few pounds here and there, you're actually in breach of PUWER from the start. It requires planned preventative maintenance. You cannot do reactive breakdown maintenance or anything like that. Having said that, PUWER's been around for quite a few years now, and there are now modern technologies coming around in terms of condition monitoring. It makes no allowance for condition monitoring. You would expect somebody in like AMC who are doing a PUWER assessment to take that into consideration when we're doing the PUWER assessment, and that's exactly what we do. But fundamentally, as the law is written, unless you're doing planned preventative maintenance, you're in breach of PUWER. Once you've done your assessment, you have to keep it. You have to keep it until the next time it's PUWER assessed. You don't have to keep a history of PUWER assessments. Once you have a valid one, you can dispose of the one that you've just used or just replaced. The key thing with PUWER is, and not many people pay a great lot of attention to this, because we quite often see PUWER assessments, as I mentioned before, done on 2 sides of A4 paper. It's not acceptable, it's not appropriate. So the person who decides who's going to do the assessment has to be competent enough to understand the machine himself. That could be the engineering manager. The person who does the assessment also has to be competent to do the assessment, and that includes knowing the machinery, the equipment, having the knowledge and experience to deal with that. So if you're in an engineering situation, the engineering manager can be the guy who appoints one of the engineers to do the PUWER assessment. Both of them have to be classed as competent to do that PUWER assessment. Very, very simplistic example. You wouldn't expect somebody sitting in your finance office to come downstairs and start doing a PUWER assessment on a workshop lathe. They're not competent enough to do that. So competency is a key thing with PUWER. There is a definition of it. To accept the definition: knowledge, skill, training, education, qualifications, experience, and ability. And we always say, if you're doing a PUWER assessment, if you're doing any kind of assessment on a piece of machine, if you look at it and your gut feeling is that that doesn't look right, it probably isn't. Likewise, if you look at something and say, what if, and then something can happen that can cause somebody some injury, that suggests you should be doing something about it. But fundamentally, if you're not sure when you're looking at something, ask somebody who understands the machine, ask somebody who has some knowledge, skill, training, education, qualifications, etc. It could be somebody internally, it could be somebody externally. I've been doing this for many, many years now. I still get phone calls from customers who I was dealing with 10 years ago. They ring me up and ask me questions because they can't get the answer internally anymore. So the structure of the regulations, this is the general layout. Regulations 1 to 3, they basically say where the PUWER regulations. Regulations 4 to 10 are your site policies and procedures, which include training, maintenance, awareness, information, instruction, signage, PP, everything like that. 11 to 24 is the physical machine, which is where we're going to spend a little bit of time today. Regulations 25 to 30 are for mobile work equipment, like MUPs or anything like that. 31 to 35 are power presses. A lot of insurance companies will insist that they do the PUWER assessment on a power press if you have one, or a guillotine or something like that. They're classed as specifically dangerous machines, and the insurance company may want to get involved with that. 36 to 39 basically say we're the PUWER regulations, but if the government decides to change anything, those 3 regulations at the end give the government the power under the law to change the regulations. Okay. We mentioned competency. One of the things in terms of competency is to ensure that whoever's doing the assessment has a very, very good understanding of the machinery safety standards. Okay. As I put a cartoon on the screen, you'd be surprised how often we come across scenarios like that. Not necessarily where we find somebody with their legs hanging out of the machine, but in terms of somebody's taking a guard off to do something and they're doing something with the machine live. But in terms of standards, there are quite a few. Don't want to scare anybody, but the next 2 or 3 slides are the standards that you should have knowledge of if you're going to do a PUWER assessment or a risk assessment machine with any level of competency or detail. I'll not go through them all one by one. 60204, electrical system, 4413 and 4414, pneumatics, hydraulics. 13849, safety control system machine, specific standard for that. It's quite involved, it's quite detailed, but it has to be complied with. 14120 is the guarding standard, so that's your physical guards, what you're making them of, how you secure them to the machine, and everything like that. 14119, the interlocking devices that you're going to fit on opening guards. 13857, reach distances over, around, through guards. You have apertures where you need to get product in and product out. They should be configured in such a way that the guarding prevents somebody putting a hand or an arm or something in where they shouldn't be. 13855 refers to light curtains and safety scanners. There is a calculation that you have to do, which is based on the stop time of the machine from a safeguard being initiated to get the correct position of a light curtain. Basically, that looks at, if I put my hand through a light curtain, that light curtain should be in such a position so that the time I get my hand through to the hazard point, the machine stops moving. So a little bit of maths to be done on that one. Don't worry about 64916. 13854, minimum gaps to avoid crushing. fairly straightforward. It's not a big standard. It just says if I want to stop my finger being crushed, the gap needs to be more than 25 millimeters and not go less than 25 millimeters, and it eliminates the possibility of my finger being crushed. Prevention of unexpected startup, that covers things like pre-start alarms on long production lines where you've got one control station and you can't see the other end of the line. Two-hand control devices are covered by 13851. If you ever have need for a two-hand control device, please do not try and build it yourself. Just go and buy one off the shelf that's specifically built and pre-configured by the usual automation manufacturers as a formal two-hand control device. There's some specific requirements in that standard that lots of people who do configure their own two-hand controls just fail miserably out. 13850 is emergency stops. Some of you may have seen a post I put on LinkedIn the other day about emergency stops. It's a very important subject. Your emergency stop is not classed as a primary safety device, it's a secondary safety device. If you're hitting your emergency stop push button, your primary safety functions have already let you down. It's your weapon of last resort. It has to work and it must be available at all times. So from those of you who are electrically biased, you cannot wire an e-stop anymore in series with the gate switch or an interlock or a light curtain. They have to be on their own input circuit. 14122 is in 4 parts, and it's basically access: ladders, stairs, work platforms, walkways. So you've got reasonable access for people to get around in. 10218 for robots is in 2 parts. Part 1 is for the robot manufacturer. Part 2 is for those people who are integrating robots into lines for end users and things like that. A lot of you will come across collaborative robots. There is a technical report for robots. It is not a standard. It has not been published yet as a standard. The best advice I can suggest is that will be integrated into part 2 of 10218 in a separate section. The key thing with collaborative robots to remember is there is no such thing as a safe robot. It depends what you put in its end effector. You can have a collaborative robot that's got limited force, limited speed, but if you put a blade in its end effector, I've got a dangerous machine. Okay, you can't rely on the robot itself. It's what you're going to do with its end effector. 619 is for conveyors, safety on conveyors, and some of the other ones are sort of peripheral standards, but they should all need to be considered if you're in that particular environment. Sort of food processed machinery, hygiene and safety. How do I clean it? Okay. Compactors and balers, most people have them on site. There is what you call a Type C standard for those. It's specific, and we regularly see brand new compactors and balers are ones that have been refurbished which do not comply with the standard. I think the last 4 we have looked at have all failed miserably and they've had to be reconfigured. One last one to consider is lighting. If you take the time to go through PUWER, you'll see in 2 places it asks about lighting. Is there sufficient lighting for the operator to do the work? Generally, if you've got about 500 lux in the area where the operator is working, you should more often than not have enough, depending on the exact task what they're doing. So just quickly looking at the structure on 1 to 9. Like I said, these are site policies and procedures, but you first have to yourself, is it machined? Does it fall under the scope of the regulations? Most work equipment falls under the scope of PUWER. Okay. Is it suitable for its intended use? Remember, we're trying to put safe machines in place for people to use. So it looks at maintenance, inspection, specific risks, information, instructions, and training. So a little bit more detail, and these are all questions in 1 to 9 of a good quality PUWER report. Have we got a site health and safety policy? Who's responsible for it? Is it up to date? Have we got inductions for training operators, contractors? Is a permit to work system in place? PPE issued? Is it logged? Is the training for the use of PPE? So if you're using respirators, you need to do face fit testing, and some respiratory protection needs training on how to use it properly. If you're in a noisy or dusty environment, for example, or you're monitoring the health of your workers, have you got noise assessments and have you done lighting assessments? Are there any risks to lone working? And are the regular meetings held by in terms of health and safety in consultation with the workforce? Okay. In terms of operators, when the operator comes to use a machine, you have to have authorized people to use it, specific people who are trained to operate that machine. You have to detail their accountabilities. So if you get a jam or a blockage, at what point do you stop the operator from clearing the jam or blockage, and do you get the maintenance guy to come and do it by lock off, tag off, or some other safe means? Have we got safe working procedures in place? Have we got manuals and instructions for the machine? Are the operators trained and records kept? Same for the supervisors. The supervisor should always understand these operators' task. If you move an operator from department to department, are they competent to work on the machines in a different department? Again, it's quite important. I once went to a site a few years ago. I was doing a PUWER assessment, and the lady operating the machine said to us, "Is you happy with it?" Yes, she says, no problem at all. Went in the following morning, she standing at the machine on the other end of the factory like a rabbit in headlights. And I said, "Are you not using your other machine today?" She says, "No." She says, "I've been asked to babysit this one." That instantly rang alarm bells with me. And as I said, she was looking at it, didn't have a clue what it was doing, hadn't been trained to use it. She'd been asked to babysit it. Not acceptable. Oops, sorry. It's very sensitive mouse I've got. So maintenance, exactly the same scenario for maintenance as there is for operators. So authorized, who's authorized? Are they trained? Are the engineer and supervisors trained? We've got safe working procedures in place for maintenance operations. Are we doing regular inspections? Is there a planned preventative maintenance system in place? That's a specific question within PUWER. Is the maintenance log up to date? And are inspections carried out on guards and safety devices? And are you recording your inspections? So again, maintenance has a lot of detail in it. Regulation 4 is the suitability of the equipment. So is it safe to use? Is it fit for purpose? Have the risk assessments been carried out? Is it ergonomically well designed? We need to look at ventilation, noise, lighting. Is it confined space? Have you addressed confined space regulations? And is it any risks to lone working have been addressed and created? So there's quite a lot to think about from a suitability point of view. 5, 6, and 7 are maintenance inspection and specific risks. So again, it re-emphasizes maintenance. Is it maintained in good condition? Are the safety critical parts checked for correct function? We'll look at that a little bit later on. One key thing on that, operator daily or weekly checks do not cover sufficiently inspections, right? That's not an inspection. If you have a pillar drill in a workshop where you've got a laminated piece of A4 paper with a dry white pen on it, where the engineer ticks the box every morning to see he's tested the e-stop, that is not sufficient to be considered as preventive maintenance. Okay. Lockout, tag out policy and procedure. You have to have a matrix. All the hazardous energy and isolation points should be identified and listed in the matrix. And you should be able to safely isolate the machine. It's a subject which can be quite involved. It doesn't have to be. There's a hell of a lot of guidance out there if you want it, but you have to be able to isolate the machine for a maintenance guy to work on it safely. And lastly on that one, written instructions available for the safe use and maintenance of the machine. Okay, that's the machine manufacturer's responsibility to provide you with that information. Sorry. So this is the picture I put up on LinkedIn the other day. That's the back of an e-stop on a machine and a control panel, which is about 18 months old. Those of you who are electrically biased will probably instantly see that that e-stop will never stop a machine because it's not connected up on the output side of the two switches. You could hit that e-stop to your heart's content and it would never work. One of the questions PUWER asks is, do the e-stops work? Do the interlocks work? We asked the question of the maintenance manager before I saw this. I said, do all your e-stops work? Are you testing them regularly? Yes, we test them every month and they all work perfectly. About half an hour later, opened the panel and found that. So read into that what you will. Regulation 10 is the certification of the machine. So the key thing to remember is just because a machine has a CE UK or a UK NI mark does not automatically mean it's safe. Those certifications are commercial benchmarks put in place by the EU and the UK to give a level playing field to machine builders across unit. They are not formal safety certificates. They're primarily a commercial certificate, but there are safety implications of doing it. So you have to have a CE UK or a UK NI mark depending on when the machine was built and what year kind of thing. Every machine has to be formally risk assessment under 1200 and PUWER assessed by its end user or an end user's agent prior to going into service. That is UK law. Okay. So regulations 24 is the physical machine itself. I'm going to put some examples up. Like I said, this is a heavily abbreviated presentation from our training course on PUWER. These are just some of the key ones. Regulation 11, dangerous parts of machinery, guards and protective device requirements. One of the HSE's favourite prosecutions when people get injured work on machinery is because they get entangled or trapped or crushed or cut by something like that. And you'll find the HSE term that is failing to prevent access to moving parts of machinery. It's one of the things that people regularly get prosecuted on. That's an in-feed, stacked in-feed with a chain lifter on a printing machine. And that's my hand. There's a big chain drive mechanism there with a cog on it. I could easily get my hand into that mechanism when the machine was running. That needs to have been prevented, sorry. Again, in Regulation 11 is the guard and fit for purpose. This is a machine that we found, cut a long story short, the operator was tasked with lubricating the chain drive with some WD-40. He kept putting it on the top of the guard where you got that little square patch and it kept disappearing. So he said to the maintenance manager, can you put a shelf or something on there so I can keep the WD-40 handy, but it stopped people nicking it basically. And he said, oh, better than that, I'll take the interlock off the guard and you can use the guard as a little cupboard. And you'll see in a minute or two the other side of the machine, he did exactly the same on the other side. So is the guard fit for purpose? No, it's not. It's not secured. Simple as that. Likewise on this one, at the bottom of that top where you can see a conveyor where there's some entanglement points, some in-running nip points and things like that. The engineer manager held his hand up to me when he asked us to look at it, and he says, I asked him to go and put a guard across the front. He says, that's what they came up with. There's a guard across the front, but they've created a ladder for somebody now to climb up and over into it. They haven't prevented the access, so the guard is not fit for purpose. If those bars across the front had been vertical, yeah, problem potentially solved. But because they've put them horizontally, I've now got a ladder to climb over the top. So again, not fit for purpose. In terms of guard fixings, this changed recently. You have to secure your guards with it requires a tool to remove, right? So there's a definition of a tool. Fixings should now be preferably Allen, Torx, security Allen, security Torx, hex nuts, hex bolts, but the use of Phillips, posi drives, slotted screws, wing nuts, or quick release catches of any kind is pretty much forbidden by the machinery directive. Okay. We still regularly see quick release catches in certain areas. You can use a quick release catch if it's backed up by a safety interlock on the guard. But again, you need to think about the timing. How quickly can I get that catch undone and get the guard open and get me hand into a machine that may still be moving? So we're back to the standard for position of light curtains, which also applies for the position of interlocks. You need to consider that same scenario. Tie wraps are not recommended or approved for holding guards in place, and you would be surprised the amount of time we actually see that kind of thing happening. So use the proper fixings. Sorry again. So this is the other side of that machine. For whatever reason, I don't know if the operator was having to lubricate that side of the machine, but you can clearly see on the top of the guard where the screws have been taken away from the interlock tongue. That particular site, if I put that site into perspective, I've been doing this about 17, 18 years now, and up until I went to that site 3 years ago, there was only once in all the previous years that I'd been doing this job that I actually said to somebody, can you turn that machine off a minute because you're going to damage somebody? Myself and my colleague Jim went to this particular site, and on the two weeks we were on site, we actually asked them to do that 7 times. So that'll give you an idea of the safety culture that was on site. Wasn't necessarily the operators or it wasn't necessarily the engineers. The problem was higher up than that, but I don't really want to talk too much about that. So Regulation 12 then moves on to fire and explosion. In this case, this is just an example I found. Somebody put the wrong cutting fluid in the lathe completely the wrong cutting fluid. It wasn't even cutting fluid. So the instant that the tool got hot working on the material, it started to catch fire. So you need to consider fire and explosion. And if you remember back to the list of standards that I showed you, there is a standard for prevention of fire on machinery. Not many people know it's there, but it is there. Discharge of hazardous materials. So we're getting into the area of COSH, basically. That's actually caustic solution coming out of the back of a machine. And that was the second time that machine had particularly leaked. This particular one, without going into too much detail, when it initially leaked and it was repaired, they actually created more pressure in the pipework where the caustic solution was in there, and the seals failed because of the increased pressure, and the operator managed to get sprayed with caustic solution. So you need to be careful with chemicals, and Regulation 12 covers the use of chemicals on machines. That leads us into COSH. Have you done your COSH assessments? It's in there, it's a specific question. Have you got spill kits? Are people trained to use the spill kits? Okay, if you're using chemicals in, around, or on machines, COSH applies. We've mentioned noise. So Regulation 12 specifically deals with noise, but it also comes up in Regulation 4, suitability of equipment. Have you got noisy machines? Are you using hearing protection? Have you done noise surveys? The image on the bottom right-hand side, the HSE have been running a promotion, if you want to call it that, for several years now with Buy Quiet. They're trying to get end users to specify to their machine builders that the machines shouldn't generate more than 70 dBA of noise. The picture on the left of that, with the what appears to be a lady with an earplug in, that earplug is not in properly, right? That is giving her no protection at all. There is a way that you put ear defenders in, and it's not just by having it hanging in your ear like that. We do a lot of work in the food and beverage industry where they have blue mop caps, but they also get provided with blue hearing defenders like that. And you quite often see people just with the blue earplug sitting in the bottom of the blue mop cap, so it looks like they've got it in, but they haven't got them in at all. Even worse. Regulation 12 also covers air contamination LEV systems. First picture on the left, that LEV system, despite that the image actually shows things being sucked up, it is not in the right place. The head of that should be a lot lower where the fumes are coming from. In the example on the right-hand side, you can clearly see a hole in the pipe in the LEV system. So that's not actually, that's sucking fresh air from the top of the machine. It's not sucking the dust away from the machine. So Regulation 12, again, still specific hazards, PPE. We've got the usual pictures for PPE. There's quite a range of it, and you need to provide it if it's needed. It's the employer's responsibility to provide all appropriate PPE for the employee. Regulation 13 goes on to high and low temperatures or any hot and cold surfaces. There's lots of areas in factories where you can find hot and cold surfaces, not just hot pipe work or hot tooling on machine tools and things like that. You can generally have panels on machines, guards on machines that get hot because there's hot things behind them. So you need to consider touching hot and cold surfaces. Same applies to cold surfaces. I'm sure we've all seen liquid nitrogen on the pipe works, and I'm sure we've all seen Dumb and Dumber. Don't stick your tongue on a cold pipe because it will stick to the cold pipe. So hot and cold surfaces need to be considered. You also need to look at ejection of hot and cold materials. Some of you may work in environments where you've got welding machines and stuff like that. If you're putting a guard around a welding cell, it needs to be a solid guard. It's no good putting a mesh guard around it because sparks can jump through mesh. Okay, so sparks and ejection of hot and cold materials need to be appropriately contained by the appropriate guard. Regulation 14 looks at controls for starting and making a change in operation. On control systems in general, PUWER fundamentally only asks one question: is the control system safe? My response to that is which control system? Electric, pneumatic, hydraulic, steam, and define safe. It doesn't. It just says, is the control system safe, which is where it comes back to competency. You have to understand what you're looking at. So fundamentally, is there a start button? Is there a reset for the safety system? Will the machine restart automatically after stoppage? Mode selectors, restricted access, normal stop controls provided. In terms of restart, a machine should never start automatically. That should be your last methodology. methodology for resetting from a safety stop. And again, those familiar with safety systems, electric controls, the reset should also always be on the trailing edge of the reset button. So that's on the release of the reset button, not the pushing and making of the contacts on the reset button. Most modern safety relays give you the facility to configure that. So in terms of that image you've got there, yes, it's a nice new panel, but it's a bit busy. There's an awful lot going on in the short space of time. In terms of restricted access, you see on the top row the manual auto mode key. If you switch in between manual and automatic mode and the hazards are different between those two modes, that key should not be left in there. It should be controlled, and it should only be certain people have access to it. Okay. Again, the auto cycle starts a mushroom head, the emergency stops a mushroom head. They're very close to each other. If I hit one, am I going to accidentally hit the other one at the same time? You'd like to think the emergency stop would have preference over that, but it doesn't always happen, I can assure you. The yellow key in the bottom, push button at the bottom, I'm pretty sure that should say reverse, not reward. So again, a few little issues with that, but remember, if you have mode selectors and hazards change or hazards present, you've got to control those keys. So stop controls, regulation 15 in itself. Can you stop the machine safely? So picture on the left, I've got 4 stop buttons. I don't really know what they're stopping. I have no idea what the white button's for. Green and black buttons, start, stop, but start and stop what? Controls have to be identified and the controls have to work properly. So picture on the left, totally unacceptable with regards to PUWER, with regards to the electrical standard, with regards to CE mark, and with regards to risk assessment. Not acceptable. The picture on the right where you've got there, is it a stop? Is it an emergency stop? Irrespective of whatever it is, it shouldn't have a shroud across it like that. Okay, it's fundamentally the wrong place. If people are accidentally pushing that by catching it with their hips or something like that, move it. Don't put a guard across it so it makes it difficult to use. Move it somewhere where it's not going to get accidentally actuated, but people can still get access to it. Sorry about that. Regulation 16 looks at emergency stops. Are they provided? Some of you may be aware that you do not have to fit an emergency stop to a machine. It's determined by the risk assessment, the design and build risk assessment. Most manufacturers will put an emergency stop on a machine, but if you don't have an emergency stop, your electrical isolator has to be red and yellow because that then becomes your emergency off device. I'm sure most people have seen black and grey isolators and red and yellow isolators. Generally, we always say to people, fit a red and yellow one, it covers all the bases. So again, the one on the left, difficult to operate because the head's missing. The one on the right, not working. And again, I looked at that one, I thought that looks a bit loose. I thought the locking ring was loose on the back of it, but the thing actually came out of my hand. It wasn't doing anything. The contact block was loose, just hanging in the back of the box as well. So again, emergency stops, remember I said that your weapon of last resort if everything else has already failed or let you down. They have to work. Regulation 17, controls in general. Can the operator see the machine from the operating position? Again, that's prevention of unexpected startup, but are the controls easily identifiable, unambiguous, positioned correctly, and on the controls in good position and not damaged? I'll leave it to your own interpretation what you think on that photograph there. Yeah, I'm not going to say too much more about that one. That was just one of several panels in that particular site that looked like that. So again, regulation 18, is the control system fail safe? Will a fault lead to a dangerous condition? Is stored energy removed and pneumatic and hydraulics also made safe? You have to consider pneumatic and hydraulic energy when you configure your safety system. So again, picture on the left, spoke to the engineer manager, said, why are there's 3 or 4 safety relays missing out the panel? And his response was, the operators were finding that they couldn't run the machine properly because of those safety input devices, so we just disconnected them all. So we disconnected them all. You should always remember, under the Health and Safety at Work Act, it is a criminal offence to willfully and intentionally interfere with anything provided for the purposes of safety. That engineer manager approved the removal of those 4 safety relays. Those 4 safety relays were integral safety functions of that machine to allow the operator to use it more efficiently. Right? He has committed a criminal offence by willfully interfering with something provided for the purposes of safety. That can be included as something as drilling a hole in your hard hat to put a torch mounted on your safety helmet or something like that, disconnecting the safety relay, shorting out a light curtain because the forklift truck driver's driven into it. Anything of that, don't do it. The picture on the right is from a printing company. That's their version of a trap key system. The problem that is all those keys are domestic lock barrels and keys. They're all exactly the same key, so there's no integrity of being the keyed alike. They're all keyed alike. Anyone would fit in another hole, and you could have taken anyone down to Timpson's in your local high street and had another one cut and keep it in your pocket. Okay, not a great lot of thought gone into that. Still on the control system, we're still looking at dangerous situations. The number of times we find devices and electrical control panels not supported, just thrown in there to make them work. Again, it's not appropriate. Likewise, the isolator, the main isolator on the back of the control panel door is not a distribution board. Okay, all those wires should be taken down to a DIN rail and terminated appropriately. If you look quite closely at the earth connections, you'll see one of them's actually got a little crimp on it. That crimp wouldn't necessarily crimp flat when that earth terminal was connected up, so there's a possibility that one or two of those earth conductors aren't actually being gripped by the terminal plate. Okay, not acceptable and not in compliance with 60204, the electrical standard. Same with earthing. That is not how to earth a panel. If you look at that closely, I think I counted up 8 or 9 earth conductors on the other day when I looked at it, but they're all dependent on that one single bolt in the middle on the right hand side. If that nut comes loose, that whole earth connection is compromised. Okay. There are a lot of requirements in 60204 for earthing. Specific ones are 1 earth conductor per terminal, and you should be able to disconnect any single earth conductor without interfering with another one. Okay, 2 key criteria, rarely complied with in most cases. Regulation 19 looks at energy sources. Can you isolate everything? That includes pneumatic and hydraulic. The old overhead bus bar connectors that we used to see in the 80s, 90s, not acceptable anymore. It's not readily accessible. I can't reach it. Middle picture, I've got 2 isolators. I don't know what to turn off. Do I have to turn one off or both off to isolate the panel? No idea. No markings on it. Simple ball valves for pneumatic air isolation, widely used, but just be aware that the next edition of the pneumatic standard is going to prohibit them. But that's a whole different topic. Make sure your isolators are readily accessible and not strapped to a post with tie wraps. This picture on the right is again something we see quite often. This is the isolator for the panel, and this is the interlock bar to the switch on the front of the actuator on the front of the panel. You turn the red and yellow button on the front of the panel round and round and round and round and round, and that would never going to turn off the machine because the bar's not connected and the isolator is just lying in the bottom of the panel. Regulation 20 looks at stability. I've just used this as a slightly tongue-in-cheek example. Is your machine stable on its own weight? Have you bolted it to the floor? If it's movable equipment, can it be made stable in all working positions? If it has flanges to bolt it to the floor, bolt it to the floor, because if you don't, it's probably going to start wandering across the floor for vibration purposes. This is a fairground. You can see in the left-hand side picture. The picture on the right is the front right corner, but the picture on the left, you can see they've done that all along the front. Breeze blocks, bits of wood to level it up. It's one of the reasons why I don't go on fairground rides, quite frankly, but there you go. Regulation 21 and 4 goes back to lighting. Have you got sufficient lighting? This image you can see on the screen is as close as I get to the actual picture. And you can see the signage on the back wall saying they have entanglement hazards. Okay, if you have entanglement hazards, at least give the operator some light to be able to see the entanglement hazard, not just put a sign up and keep them in the dark, basically. I mentioned the lighting standard. The HSE buy into that quite heavily. As I mentioned before, generally 500 lux at a work surface is sufficient depending on the task, but you should always have sufficient light for the operator to do the job properly, and you should do lighting assessments at the same time as you do noise assessments. 22 looks at maintenance. Can safe maintenance be carried out? Again, remember right at the start, it asked about maintenance. Is there safe access around the machine for the maintenance guy? Have the maintenance risks been assessed and controlled? Do only competent personnel carry out maintenance? Okay. A lot of people think the operator that uses the machine day in, day out is the person at most risk from the machine. Not necessarily so. The maintenance guy is quite often more at risk because he has to do fault finding with the power on and the machine running. Okay, so your maintenance engineer risk assessment will be different to your operator risk assessment. Okay, I mentioned willful interference with safety systems. If you have a safety interlock tongue key on your key ring or anything like that, and you're using it to get through a guard to mess around with something, you're breaking the law. Okay, it's as simple as that. You're willfully interfering with that interlock to do something that you shouldn't be able to do. The picture on the right is this particular company's version of lockout tagout. The bolt is actually one of those garden gate bolts that you can slide and push it up or slide it down. There are 3 keys on that padlock, probably 4. One's got the key in, one of them's not locked shut, and there's only 2 of them on the side where the bolt's actually being pushed across. And out of that 2, one of them's got the key in it. So out of those 4 locks, there's only actually one of those locks being effective. Okay, lockout tagout is an art in its own right, and it needs to be treated accordingly. Regulation 23's flow directions. Again, felt pen, not ideal. There is coloured tapes you can get to mark pipes up. And on the picture on the right, at least the painter had the decency not to paint over the label to say it was a gas pipe. But yellow is the right colour for gas as it happens. Rotational directions in terms of markings. Most people know that on a grinding wheel there's an arrow on it which tells you which way it has to be mounted onto the grinder itself. And in terms of the garden on the left-hand side one, I would expect the abrasive pad to be running from top to bottom because the spark guard's at the bottom. But again, if you look at both of them, they've both got very small spark guards on themselves. There's a trend for these to be made smaller and smaller by the people who make these kind of machines. Yes, you have to wear eye protection and PPE when you're using them, but how you used to find them 10 years ago is no comparison to the ones, as you can see, that you buy new these days. Reg 24's warnings. Have you got the appropriate PPE signs up? Have you got the electrical warnings up? Are the signs of good condition? Are they damaged? And are they in the European format and understandable? Okay, I put the word in there, understandable, is because we have a vast range of nationalities working in the UK, have done for some time. Language, English isn't necessarily everybody's first language, so your signage has to be understandable. EN ISO 7010 is the standard, and that picture there is very true, but you can't rely on common sense. Just some examples of signage. I'll not go through them because we're pushing on for time. The one that usually catches most people out is the bottom left-hand corner one. That actually is the sign which warns of unexpected startup or startup without warning. Shouldn't start up without warning, but it's something else you can use there. So that's very, very quickly, very, very rapidly some of the fundamentals of safety. I mentioned PUWER saying is the control system safe. When we do PUWER assessments, our PUWER assessment document is 128 questions long. Okay, so that gives you the level of the detail that we go into as competent people in doing the PUWER assessment. But we also had another 4 at the end. And I've got we got any concerns of the electric, the hydraulic, the pneumatic, and the safety rated control system. Remember, PUWER just says, are the control systems safe? That's it. We go into a little bit more detail than that to give you a more holistic view of your machine and stuff. And quite often, this bottom one, the safety systems, where we end up writing the most. So that's it. Just about on time kind of thing. There are our contact details, and that's the team we've got. It's Paul, myself, Steve, and Jim. Myself, Paul, and Steve are ex-PILS. I'm also ex-TUV. Jim is ex-Omron with myself as well. We've got bags of experience. In the wider team, we've got about 120 years experience in doing this kind of thing. So I've gone through the presentation quite quickly, but if anybody has any questions or anybody wants to contact me afterwards with specific questions, more than happy to help. Okay. So I'll leave that up there for a second or two. Jonathan, I don't know if you want to come back in with any questions that have been picked up during the presentation, see if we can answer 1 or 2 of them quickly now.
Yeah. Yeah, brilliant. Thanks for that, Les. We've had a few questions come through. Actually, I'll read them out. So the first one is Type C standards aren't always applied where available. This doesn't always happen. Is it acceptable if a Type C standard exists for it to not be applied in lieu of other standards? If not, what is the consequence to the users?
Where there is a Type C standard, you should use it as much as possible. That should be your first port of call, because that Type C standard will contain all the useful information you need for that machine that it applies to from all the other standards. The basis of a Type C standard is it puts all the information in one place for you, for example, a press, a guillotine, something like that. In theory, it actually saves you trawling through the rest of the standards for your key safety functions. The thing to remember with standards is PUWER is law, CE marking is law, UKCA is law, risk assessment is law. Standards are not law. Standards are classed as good technical guidance documents to help you comply with the law. The standard themselves, not law, but if you were stood in front of a judge and the judge says, did you use the ISO 13849 to design your safety rated control system? And you said, no, I didn't, Your Honour. You're in trouble. But likewise, if you say to him, well, I did for most of it, but not for all of it, and he said, well, where's your documentation to show me what you've done? And your documentation's in your head and not written down, you're in a sticky wicket as well. He's not going to be happy. As far as he's concerned, you haven't done it. Okay. If there's a Type C standard, use it. Okay, it'll give you all the key functions. It'll even tell you for your safety system functions what performance level, what wiring architecture you should achieve without having to go and look elsewhere for it. Well, they're not law, but if you don't use them, you need to have a damn good reason for not using them, and you need to clearly document why you didn't use them.
Brilliant, thanks, Les. Really comprehensive answer. Next one, sticking with standards actually, BSEN ISO 12100 machinery risk assessment. Some suppliers won't share their 12100 assessment citing intellectual property restrictions. What options would you have to kind of access them or argue the case? Okay,
so the in that scenario, the manufacturer he's doing his design and build risk assessment. He considers that to be his intellectual property. He has to do it by law. That risk assessment has to go into the technical construction file for the machine to validate its CE or UKCA mark. The technical construction file itself is the property of the machine builder, right? He does not have to share that with anybody unless there's an incident and a prosecuting authority or some of the authorities, which can be the HSE, can be the Environment Agency, be anybody like that, they can request it and they do have to provide it. They don't have to provide that design and build risk assessment to their customer or the end user. However, there are ways around it. You can write the machinery purchase and specification, which says that the manufacturer will provide that as part of the purchasing process. We've done that several times for people. We have a 45-page document which we work with several clients, and we configure that to their specific requirements. But it actually says in it that you have to share specific information, the risk assessment, your 13849 calculations, your 13849 performance level determinations. They're in the same scenario as that manufacturer's 12100 design and build risk assessment. Has to sit in the technical file, but as part of the technical file, the machine builder doesn't have to share it. But if you make it part of your commercial terms, and you have sufficient buy-in power to be able to do that, then put it in there, do that. And if you can actually say to them, we have done it with two clients. We've put a retention built into the purchase and specifications. Until you give us all the documents that we've requested, including your design and build risk assessment, we're going to put 2.5% retention on the purchase price. The trouble with that is some machine builders just jack up the price 2.5%. So they still get their money and they just say, no, you're not getting the 12100 risk assessment. It's a tricky one, but there are ways and means of trying to get around it. Whoever has asked that question, by all means, drop me an email or give me a ring. you know, we can help you with that scenario. I'm not going to say we can guarantee to get the information for you, but there are ways and means you can ask for it in certain ways, which puts pressure on the machine builder to give you it.
Brilliant. No, thanks for that, Les. I'm sure they will reach out to you with that one. And the next one is maintenance logs aren't a requirement, but if you have one, it is a requirement to maintain it. Why is that?
If you're doing maintenance on a machine, you should have maintenance records. There are software packages out there who can manage your planned preventative maintenance for you. If you have it, you should be updating it and you should be completing it. If you don't have one, you should get one. It's as simple as that. If you have an accident on a machine and an operator is injured, in any way, shape or form, the HSE think it's down to lack of maintenance, and they say to you, where's your maintenance records? When did you last service that machine? You know, when did you last have the LEV system tested, because it's not sucking dust out of the atmosphere and I've now got somebody with lung disease? You have to be able to demonstrate that you're maintaining that machine in the way the manufacturer intended to it. The manufacturer of the machine has to give you the maintenance instructions, and you have to follow them under a planned preventive maintenance perspective. Okay, maintenance has to be carried out. I can talk to you about machine maintenance for hours if you want to, but we ain't got the time. You have to be doing maintenance, you have to record your maintenance, and you have to document it. Simple as that.
Well, that's brilliant. I think if we have a number of engineers who have dialed into this or who listen on the YouTube channel afterwards, I'm sure you'll get many a phone call of opportunities to talk about maintenance, Les. So they're the three questions that we've got. I'll wait just a moment to see if we have any others pop through on the portal. But whilst I'm waiting for that, just wanted to say thank you, Les, for taking the time out to take us through that. PUWER is always quite an interesting one, from my point of view anyway, and I'm sure for other people's as well. Bit more about the, oh, hang on, we've just had another question come through. Apologies for jumping on a little late. Always good to listen to professionals, so thanks to Les for an interesting look into PUWER, and also to the committee for arranging the session. Oh, brilliant, thank you. So, yeah, thanks again to Les. Our next webinars should be going live to be able to sign up for. The next one being on the 29th of March, where we've got Chris Stone talking to us about fire, and then another one on the 4th of May, which is going to take a look at some of the new ISO risk management standards and how, had it have been applied to the Death Star, then maybe it might not have been designed so poorly to allow it to have been blown up. That being on May the 4th, Star Wars Day, and an interesting one that I'm sure you'll be able to sign up to. So any Star Wars fans or risk management fans out there, then I'm sure you'll be in for a treat. So the only thing I will add onto that before I hand back over to Julie is, again, yeah, thanks for taking the time. The session will be available on the YouTube channel within the next 24 hours or so. And thank you to those that have shared ideas that they'd like to see for other webinar topics, such as this one, which has led us to inviting Les along today. So thank you very much, and back to you, Julie.
Thank you, Jonathan, and thank you, Les, for an excellent presentation. As Jonathan said, the recording will be on the YouTube channel in the next day or two, probably tomorrow. And those of you wanting attendance certificates, they will come out this time tomorrow. So I'd like to wish everyone a good afternoon or a good evening, wherever you are in the world. We hope to see you at the next East Anglia branch meeting. Goodbye, everyone.